Ladies and gentlemen, welcome to the Transnet podcast. My name is Milton Ngosi, and we're coming to you from the Transnet Pavilion at the Africa Rail Conference. And today, I'm joined by Dr. Emma Molobi. She's the specialist rolling stock technology at TFR. Welcome, Dr. Molobi. It's good to have you here.
Good afternoon, Milton, and thank you so much for inviting me.
Wonderful. I've been looking forward to talking to you all morning. Finally, we are doing it.
Yeah, great.
And it's great to be here. So much to learn, so much to see.
Definitely.
Tell us about how you visualize the future of railway operations and rolling stock maintenance.
Milton, that's quite a very interesting question, and it's a universal question basically, because with all the predicaments that we have in the railway infrastructure, but we are still looking forward to the future. So the way I see the future of railway infrastructure is basically we need to understand what we need to do. We need to go back to basics, and that's the first thing. And by going back to basics, it's moving freight from the road to the rail, as per our white paper on the national rail policy in South Africa. So that's the main basics of visualizing the future of the railway industry. But in terms of realizing this visualization and realizing these efforts, we need to understand the current environment that we are in. We are in a disruptive era, whether we like it or not. We are in a disruptive era whereby infrastructure, whereby business operations have changed, and because of innovation. And that is something that is beneficial to the society. So we definitely need to adapt. We need to be agile. And so the future of railways for me is an integration of the 4IR technologies. It's the integration of our traditional technologies, everything that applies to our system, especially in Transnet, in order for us to be able to do preventative maintenance, in order for us to do predictive, and also continue with condition-based maintenance for a sustainable railway environment. We need to be able to use these technologies to be able to look at the current predicaments that we have, especially with regards to maintenance. So basically that is the future of railways, an integration of the technologies we have, the traditional technologies together with the 4IR technologies for a sustainable environment.
When you say 4IR, Dr. Molobi, you are already including in that thought, the way you visualize the future, the concept of AI. Is that correct? Or AI is where you want us to go as we integrate 4IR?
So, very interesting, Milton. So 4IR technologies, we've got the dimensions of the 4IR. And within the dimensions of the fourth industrial revolution technologies, we have AI as one of the dimensions. We have advanced manufacturing, which is some of the dimensions. We have nanotechnologies, we have hydrogen economy. So there's a lot of dimensions within 4IR. So it's a holistic word and it's a buzzword that we normally use, but there's so many different subjects and integrations of the different technologies within 4IR. So definitely AI is one of the things that needs to be looked at. Subject matter experts have to be able to relate that technology to our current system and make it work for us.
So it's all in good to have these big ideas, right? So how do we do it in a cost-effective way so that the engineering solutions which are pertinent to rolling stock assets actually manifest in the way you see them?
Definitely. So Milton, we have all these technologies and they are all nice to have. And now you asked the question in terms of cost effectiveness. One thing that I always stress is we should not forget traditional methods of doing things. And when I answered, I think it was the first question in terms of the future of railways, I spoke about back to basics. So I'm just going to give a current example in the engineering environment. We have different types of rolling stock assets that are subjected to different operational environments. and it leads to deterioration of those assets. So how do we bring them back? Imagine if your life cycle has been reduced, the asset life cycle has been reduced. It leads to costs, premature maintenance. It also leads to long lead times with regards to ordering spare parts, right? So back to basics would be to refurbish, to repair. We're already using welding processes, we're already using cladding processes, we're already using coating processes so that we can get these assets back into the industry without ordering them. So those are back to basics. We just need to build up on it. Currently, we are building up on different welding technologies that are now part of the 4IR industry, but they started as traditional technologies. So everything is nice to have. Back to basics. Let's remember our traditional technologies and build up on them.
So you are reminding us that while we talk about the future and nanotechnology and AI, but we have to draw from our very beginnings, the back to basics.
Yeah.
It's important that while you're going to the future, you remember where your roots lie.
Yes, you need a foundation.
You need a foundation. Thank you so much for that. That was beautiful. Can I move you forward a little and ask you about some of the technological railway solutions for maintenance delays that need to be investigated? So give us your sense of what needs to be investigated there with the maintenance delays.
So, Milton, in the railway industry, maintenance delays are a lot of our railway industries have a predicament of maintenance delays. So it's not only the South African industry that has a problem with maintenance delays. You have other railway industries globally that have a problem. So I think the main thing is to understand what is causing those maintenance delays, right? Understand what the cause is. So from our point of view, the cause of maintenance delays is the long lead times that are associated with purchasing spare parts. That is one of the things. The other thing is the usage of obsolete assets, meaning that we cannot get them in the market, and also obsolete manufacturers. And the other most difficult part is being able to source small quantities. We get situations where we have failures and you just want to replace one asset. However, you can't do that because you have to buy in bulk. So those are some of the things that are leading to our maintenance delays. So now we know what the problem is. So there is different technologies that can actually assist, and one of the technologies that I'm also very passionate about is additive manufacturing. It's one of the 4IR technologies that has been implemented in a wide range of industries. It is used in the aerospace industry, it is used in the automobile industry, and the railway industry is now climbing into that bandwagon. I know internationally and globally, it's something that is already used. So your next question is why? Why use it? How is it going to help us? So it's basically a process whereby you can manufacture near net-shaped asset, meaning after manufacturing you don't need a lot of post-processing. The turnaround time is quick, and you remember we mentioned the long lead times, and you can manufacture close to the point of use. So those are some of the advantages of this technology that needs to be explored. In as much as it has been explored, especially in the polymer industry, we need to explore it in the metal industry. And the next question is, why are we not jumping on the bandwagon when other industries are? We definitely need, and that's what we're currently busy with, we currently need to do a feasibility study. Before you take up any technology, you need to understand, is it financially feasible? Is it legally feasible? Is it technically feasible? And that's what we're currently looking at, comparing traditional methods to additive manufacturing in terms of looking into the part itself, the cost of the part, the mass of the asset or the part, and also the turnaround time with regards to that. So those are one of the technologies that we're currently looking at.
And I suppose, as you were talking about the metals, the material is central to this concept.
Definitely.
Yeah, the materials you use to build the manufacturing capacity.
Yeah, the materials are very important, and you've touched on a very important subject there. The materials are very important because let us say we are using additive manufacturing and it uses wire or powder and we cannot attain it. That's also a backlog because it will also lead to long lead times. So in terms of the feasibility, we should also look into how easy it is to attain the material, and will it give us a structure that has good mechanical and metallurgical integrity.
I'm told that we are running out of time.
Okay.
I want to close
All right.
by asking you about how confident you are that your vision of where we need to go will be realized, and how long might it take, and your final thoughts as we close this wonderful discussion.
Okay, thanks Milton for that. So in closing, the fact that I'm in a railway industry, it shows how much passionate I am about the rail industry, about the engineering within the rail industry.
I can feel the passion in your voice.
So by that in itself, being in the railway industry, being in Transnet, it shows how much confidence I have in that future, that we will be able to attain it. And in the first place, that's why we are here. That's why we are here as employees of Transnet, to realize that vision. How long it might take, I'm not quite sure to put a timeline to it, but what I can say is we have started with the foundation, we have started with the background work just to realize that future.
Thank you so much. Ladies and gentlemen, Dr. Emma Molobi.
Thank you.
Thank you so much.
Thank you,
Great to
Milton.
having you.
Thank you.
See you again.